Alright, so we're going to do a quadratic word problem. Pause the video and read the question. Okay, now we're going to start this problem like we do every other problem with the sketch here. We know H is in the same place as the Y, and the T is in the same place as the X. If I rewrite that, that's what I get. Notice A asks you, what does T and H represent? So T is going to be time, and that's in seconds. I know that from the problem. T seconds. H is going to be your height, and that's going to be in feet. Again, I can pick that up from the problem, H of the object in feet. So for our sketch, this is going to be our time, and this is going to be our height. Alright, this problem looks pretty big, 16, 35, and 5, so I'm going to show you how to do this in the calculator. So part B asks us to sketch the graph labeling the vertex, the X-intercepts, and the Y-intercept. So we're going to find those on the calculator. So open up your 89 or your 83 if you want to do this with me. And for y equals, we're just going to put in the function. So go ahead and hit y equals negative 16x squared plus 35x and then plus 5. That needs to be a negative sign, not a minus sign. Remember, if it starts it, you have to use the negative. Okay, make sure you got it in there correctly and then hit graph. Okay. Now, the first thing we're going to find is the vertex. Now, you can see that this parabola, you know, is turned down because A is negative. So that vertex is a maximum and it's off the screen. So we're going to hit window. We're going to change the Y max because that's what we're changing is the Y axis. We're going to try, let's try 30 first. And you can see that that stretches it out, and I can see more at the top. So there I can see the vertex. Alright, now remember how to find the vertex in the calculator. Hit second, trace, and you either pick minimum or maximum, and since it's a peak, since it's turned down, you pick maximum. And remember, it always starts right here on the y-axis. So you're going to go up there to the vertex, and you're going to go to the left of it. So make sure it's flashing to the left of the peak. Doesn't have to be on it. It needs to just be close to it. Hit enter, and then the right bound, you're going to go to the right side of the vertex and hit enter. You can see two triangles there barely, and then guess, hit enter again, and you get 1.09 comma 24.14. Alright, now that's the vertex. Now let's find the X-intercepts. Alright, here's how you find the X-intercepts. Remember, one way I showed you, X-intercepts are found by putting 0 in for Y. So what we did here was we went back to Y equals, and for Y2, I'm going to put 0. Now remember, this is a system. So y equals 0 would graph as this blue line cutting across this way. So if I have this parabola going on this way, I have to find the solutions to those. So I'm going to find the intersections. That was kind of a little shortcut that we did. So you're not going to be able to see it graph because it's graphing along that line there. Alright, now you're going to hit second, calc. You're going to go to intersect. And you see you're going to have to get close to the first intersection because you're going to have to do this twice. So you can see the cursors there. I'm going to hit enter 3 times. And there it is. Negative 1.35 comma 0. So that's one X-intercept. And let's find the other one. I'm going to do the same thing. Second, trace. Go down to intersect. But now we're going to go over to the other one. See where my tracer's going. I'm hitting the right arrow. I'm just going to get close to it and hit enter 3 times. And I get 2.32, comma 0. And those are your x-intercepts. Now, how do I find y-intercepts? Y-intercepts happen when I put 0 in for x. So all you have to do is hit trace, 0, enter. And you get 5. So the y-intercept is 0, 5. Again, I put 0 in for x and I solve for y. For the blue, I put 0 in for y, solve for x, and for the vertex, I found the maximum value. So to give a good sketch of that, what's happening there is you have time and hot. Got these ordered pairs 1.09, comma 24.14. You got that one is negative 1.35, comma 0. This one, 2.32, comma 0. And then you got 0, 5. So there's the rough sketch of that. Alright, now remember the x-coordinate is time and the height is your y-coordinate. So when I look at this, at 2.32 seconds, the height's 0. At 1.09 seconds, the height's 24.14. At 0 seconds, it's 5 feet. And at negative 1, I think I wrote that one wrong. Yep. Put the decimal in the wrong place. There we go. At negative 0.135 seconds, the ball or the game is at 0 feet. So one of those shouldn't make sense to you. There really can't be negative time. So he's throwing this game, and 0 would be the time where he's just standing there holding it. And then after that, you can see that the game goes up, 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 up. In the first 1.09 seconds, it traveled the 24 feet. And then it dropped from that point down. So this part of the graph, I'm going to highlight it. This part of the graph is really the only part we need to look at. Now what about this part below here? Well, if you think about these points, this would be something like 3, comma, and then you would have a negative y-coordinate. I don't know what the y-coordinate would be. You could plug 3 in and find out. But what that means is at 3 seconds, it's at a negative height, which means it went through the ground. So probably this red part is the only part that's really going to make sense. So at what height from the ground is the video game released? The answer to that would be at 5 feet, because at 0 seconds, the game is at 5 feet. If the window is 25 feet above the ground, will Sam have 0, 1, 2, or 2 chances to catch the video game? So what is the highest height that the game went? The highest height would be 24.14. So the game never reached 25 feet. So he would probably have 0 chances. Unless he reached down and grabbed it. But it would not reach a height of 25. If Sam is unable to catch the video game and John doesn't catch it, when it comes back down, when will it hit the ground? Well, if it hits the ground, the actual height of it is 0. So there's 2 times when the height is 0. At negative 0.135 seconds and at 2.32 seconds. And we've already decided that 2.32 seconds makes the most sense because there can't be negative time. This part doesn't even happen. What does the part of the graph below the x-axis represent? This part right here represents the game going into the earth if it hit the ground and went below the surface. Now, over here, it doesn't mean anything because that's negative time anyway. But this is negative height, so it's under the ground. And that's a quadratic word problem.